Okay, so brief introduction to what isomers are then. You've come across isotopes before. Isotopes were used in chemistry, but usually, well, chemistry and physics. So when there are different types of the same element. So it would be different, it would still be carbon maybe, but there'll be different types of carbon, carbon 13, carbon 12, carbon 14. An isomer is a different type of molecule. So now what in the case of an isotope, you have the same atomic number, but you have a different atomic mass. In an isomer, you have the same molecular it's the same molecular formula, but a different structural formula. So I'll draw an example to show you what I mean. So let's imagine we had 4 carbons, and we make a very simple alkane, like butane. So this is butane. I know it's called butane because it's got 4 carbons. That tells me the beginning of the name, bute, and it's got all single bonds. So I know it's an alkane. That tells me the ending of the name. So that tells me the ane part. So together it's butane, butane. So this is butane. Now what I've drawn there, we call that a displayed formula. The molecular formula is just simply how many of each atom does it have. So it's going to be C4H10. The general formula for alkanes is always CnH2n plus 2. And that's because every carbon is going to have 2 hydrogens on it, so that's the 2n, but it's also going to have another 2 at either end, so that's the plus 2. So that's the general formula, but you can also try and make it yourself and find it out as well. So that's the displayed formula, the name, the structural formula. Over here is the general formula, and now I think I just messed up there. That was the displayed formula. That's the name. This is the molecular formula. That's the general formula. I will name these in a moment. And this one will be the structural formula. So what I do now is I go down the spine of the molecule. I look at each carbon and I ask what is on that carbon. There are 3 hydrogens on the first carbon. What about the second carbon? There are 2 hydrogens. The third carbon, also 2 hydrogens. And the fourth carbon, 3 hydrogens. So let's just name these types of formula. Okay, so there we go. So that's the displayed formula, this is the general formula, this is the molecular formula, and this is the structural formula. So an isomer is an isomer. That's a terrible sentence. That's why I always tell off other teachers for saying what's an isotope, because that's like saying what's a type. It doesn't make any sense. In the same way, you can't say what's an isomer. You can only say what are isomers or what are isotopes. So an isomer is, or I've just said it again, isomers are molecules that have the same molecular formula but different displayed and different structural formula. So I'll use a different color. I'll use green to draw my other isomer. So I still have, it must be C4H10, so it means I only have 10 hydrogens and I have 4 carbons. So how could I rearrange this? In fact, maybe you could have a go at drawing a different molecule. The rules are simply that every carbon must have 4 bonds and attach to something, and every hydrogen must have 1 bond. And then so you can just imagine that they're like Lego bricks or little things that connect to each other. And wherever you draw a carbon, it's got to have 4 arms, and every arm must have something on it. Wherever you draw a hydrogen, it only has 1 arm, and that must be connected to something. So no spare bonds, and nothing can have any more than that many bonds. So have a go at drawing a an isomer of this. So yeah, so that is an isomer of butane.
How would you write its structural formula?
Good question. How would we write the structural formula? So I'll get to that in a moment. But first of all, let's just acknowledge the fact that it's got the same, it's got a different displayed formula, and it's got the same molecular formula. So it's still going to be CH4H10. And it's not butane anymore, by the way, because it's not got a chain of 4. It's got a chain of 3, and then this little group here. I'll talk about what that group is in a moment. But one thing I will tell you that it's going to be something to do with propane. We'll talk about naming it as well. I think naming it is beyond GCSE, but it's still good to just generally get familiar and sort of fluent with the language of organic chemistry. So, okay, displayed formula then. So first of all, we start from the left. We look at the longest chain, because we've actually got another chain down here now, haven't we? We look at the longest chain, and we start off with CH3. Then we go CH, and what do? We draw a bracket, because that's around this C, and we go CH3, close the bracket. So that H and the CH3 is all attached to this C, right? So if I did some boxes, some transparent box. Oh, that's quite good. That was the last time I used that box. So let's make a different color. And let's make that one blue. So just so as we're clear, that carbon, oh dear. I want the square, please. Oh no, come on. I'll move it back afterwards, fine. That rectangle, that carbon is that carbon down there. Moving back. And this carbon is that one. And no. Oh. No, now I've drawn an arrow. So there you go. That's that C, and then the final C that we need to draw. So then it's CH3. Does that make sense?
Yeah.
So it's very similar to how we do when we do other types of molecular formulas. For I'll try and think of another example. I can't think of a good example, but we use these numbers in other ways, but in a slightly different, in a very similar way, where we might do an OH and then 2, for example. We might do something like that. But anyway, it starts to sort of make sense. It starts to feel normal. What about naming it then? It's this bit here, and this thing you do need to know for GCSE, I believe. This group, we can call this a group, is called a methyl group. Now, methyl, meth, because it's one carbon, and then it's attached to another chain of carbon, so it's called a methyl group. And then what would we call it? Well, we would call it methyl propane. Now, yeah, we call it methyl propane. Now, you could call it 2-methyl propane, because that would tell you that it's on the second carbon, but it can only actually be on the second carbon, because if it was on the first carbon, it would just be butane, but just bent in half. Or if it was on the third carbon, it would just be, because it would just go like that, right? So because it's on the second one, we've only got one chain, and so we just call it methyl propane. Okay.